Pre-calculus begins in this course with the basic functions: y equals x squared, y equals 2 to the x, y equals 1 over x, y equals 1 over x squared, y equals x cubed, called respectively the squaring function, the basic squaring function, the basic exponential function, the basic reciprocal function, the basic reciprocal square function, and the basic cubing function. We evaluate the function at standard x values, and the standard x values will be, for each function, will be every element of the set, -2, -1, -1 half, 0, 1 half, 1, 2, for which the value of the function can be calculated exactly. And this doesn't mean calculated with a calculator. It means calculated exactly on paper somehow. Okay? And as we'll see, some of these functions cannot be evaluated exactly and written as a decimal number. Okay? At some points. But every function can be evaluated at most of these points. Well, just to start, let's just look at the function y equals x squared. Okay? The basic function is y equals x squared, and we're going to evaluate it at every one of these points. So, well, -2 squared is 4. -1 squared is 1, -1 half squared is 1/4, 0 squared is 0, 1 half squared is 1/4, 1 squared is 1, 2 squared is 4. If you don't understand all of those completely, you need to look at the more detailed explanation I've given in a video that'll be clearly associated with this. Okay, so that was very easy. If it's not very easy, you got to get your arithmetic up to par. And you probably want to look at the more detailed explanation. Well, then we plot these xy points on a set of coordinate axes. Again, more detailed explanation goes into more detail, as you would expect. Okay, so actually, you know, I put 4 up too high. 4 should be about here. So we'll just kind of obliterate that. Okay, now we've got the x-axis from -2 to 2, because all the x values are between -2 and 2. We scale the x-axis accordingly. We cut the interval from 0 to 2 in half to get 1, and we cut the interval from 0 to 1 in half to get where x equals 1/2. And on the other side, we cut this interval in half to get 1, this interval in half to get 1/2. Cut the interval from 0 to 4 in half to get 2. From 0 to 1, from 0 to 2, we cut it in half, we get 1. Cut the interval from 2 to 4 in half, we get 3. And we're going to need 1/4. We're going to have to subdivide, we're going to need y equals 1/4, okay? So we're going to have to subdivide the interval from 0 to 1 in half. That gives us 1/2. I'm not going to label it. And then we cut that interval in half, we get 1/4. There's where x equals 1/4. And of course, we could cut this interval in half. So we've cut the interval from 0 to 1 into fourths. Okay. Now we plot the points. Okay, -2, 4. Well, the line x equals -2, vertical line here, and the line y equals 4, horizontal line here, and they meet at the point -2, 4. And then -1, 1, well, the vertical line where x equals 1, horizontal line where y equals 1, meet at this point, and that point would be our -1, 1. Now, I'm not going to label the coordinates of every point. I'm just going to go ahead and draw the rest of them, but when you do the graph, you do need to label those coordinates. Okay, -1/2, 1/4, there's -1/2, and I didn't put my negatives down there. You got to get used to the idea that I can be a little absent-minded, but usually I catch myself. Okay, so -1/2, 1/4, there's -1/2, there's 1/4, there's our point. 0, 0, 1/2, 1/4, 1, 1, and I want to be a little careful here. We'll go ahead and extend this line across here, extend the line up here. The point 2, 4, is right about there. Okay? This is the graph of the basic squaring function. I got to abbreviate function, ran out of room there. So we have here the function y equals x squared. The basic graph. The domain of this function is a set of all its x values. Okay, well, the function at this point just consists of these points. Okay? The x values is -2, -1, -1/2, 0, 1/2, 1, 2. The range gives the set for the y values. The range is a set of y values. And the y values are 4 and 1. And of course, both of these points have y value 4. Both of these have y value 1. These both have 1/4, and this has 0. So the range just consists of the numbers 0, 1/4, 1/4. And we don't write 4 down twice because it occurs twice. The range is a set. You don't list elements of a set twice. Okay? Now, if you list the table, you're going to have 4 twice. A lot of times, you want to know that 4 occurs twice because that's an important property of the function. But that's the range. Now, we also define the extended basic function. Okay, there's the basic function. The extended basic function is a function you get starting here, ending here, if you have the smooth curve that represents the squares of all numbers between -2 and 2 as y-coordinates. Okay? So, the extended basic squaring function has domain well, to get all the points on this curve, you got to use all the points from -2 to 2 as your x-coordinates. Of course, since there are infinitely many points, you can't write out a table for it, but the domain is going to consist of all numbers from -2 to 2. And I started to write this domain with a set bracket, meaning I would have wanted to use set builder notation. And I don't want to confuse the issue with set builder notation. I'll just say the domain is the interval -2, 2. And this is the notation for a closed interval. All the values between -2 and 2, including -2 and 2. So here's the domain. Okay? The interval from -2 to 2, including the point at -2 and the point at 2, which is why I have big old filled in dots at those points. Now I assume you understand interval notation. Again, if not, go to the extended explanation. So the domain is the interval from -2 to 2. The range is a set of all the y values. And the y values go from 0 to 4. Every y value between 0 and 4 You can take that y value, draw a horizontal line, find a point, go down here and find the x value it came from. So every y value between 0 and 4 comes from some x value. In fact, in this case, except for the 0 number, comes from two x values. For example, 1 comes from x equals 1 and from x equals negative 1. So the range, in any case, is the interval, closed interval, 0 to 4. Closed because 0 is included, 4 is included. That's the extended basic function. Now, there is also the complete basic function. Complete basic function, the trend continues. The graph is getting steeper and steeper. It's going to continue getting steeper and steeper, but it never ends. It goes as far as you want in that direction, even though you're going to have to go way up in this direction. And it goes as far as you want in this direction, but of course, you got to go way, way up if you go far out in either direction. So, okay, I'm going to kind of indicate that like so. And it looks like it's almost vertical, but it never is vertical. There's always some deviation from vertical because you can always go a little further out and go a lot further out. Okay, so the complete basic function, and I'm using this color for complete, is the one that extends to all possible x values. Now, this is the x squared function. Doesn't matter what your x value is, you can evaluate it. So you're going to have a y value for every x value from negative infinity to infinity. So the complete basic function, the domain, is the interval from negative infinity to infinity. And this is an open interval because infinity isn't a number. Infinity is just something you keep approaching. You never get there. So you never get there, so you can't have infinity as an endpoint. So it's not a closed interval, it's an open interval. In the range, should be pretty clear. Thing keeps going up, the lowest it gets is 0. So the range would be zero, infinity. Okay, so now we see that we have the basic squaring function. We have its domain and range. We have the extended basic squaring function, which fills in the curve between the discrete points that we have for the basic squaring function. And we have the complete basic function that just extends to all possible x values. One other thing, the way we can write this function, okay, the basic squaring function can be written as the set of points that we get here. So, don't have a lot of room, but you'll see me insert things all over the place. So the best place I can insert anything is here. That's where I have the most another notation for the basic squaring function. It's the set of ordered pairs that represent these points. So we have the point -2, 4, -1, 1, -1/2, 1/4, 0, 0, 1, 1. Uh-oh. I went and got careless again. Okay. Gonna erase that. And try to clean it up a little bit. Okay, we have, before we get to 1, 1, we have 1/2, 1/2, 1, 1, and 2, 4. So this is what the basic squared function is. It's this set of ordered pairs. For a function without that many ordered pairs, it's a convenient way to write it. For a function that has an infinite number of values, it certainly isn't practical to try to write out every possible ordered pair. In fact, it's totally impossible. But the ordered pair notation is important. Okay, well, there's more to it, but right there you have an introduction to one of the basic functions. We'll go ahead and look at the others a little more quickly than this one.